One of the classic experiments in physics is in optics is to prove that the image distance is equal to the object distance. So in this experiment we have a mirror, and we have kept the mirror here, and here we have a representative of an image, a rod, so that we can align the image, and this is our object rod. So what we're going to do is now we're going to keep our object in such a way that the image of this object is aligned with the white rod. And usually you would think that there would be many positions for that, but there would be a unique position in which the image and the object would align from all angles. And that's what we mean by removing parallax. So you can see that at various angles, the red image rod, the object rod, you can see the image of that object rod is red in color in the mirror. It's aligned with the representative white rod, right? So we're making sure that at various angles they both are aligned. All right, so now let's mark these points. So this is what we mean by removing the parallax. So once we find the parallax, we need to mark the point. So can you hold this rod? Okay. So I'm going to mark it in paper. Can you remove this rod, please? So here we have marked this point, and I do the same with the white rod. So I mark this point. Can you remove the white? Yeah. So there you go. So I have marked these 2 points, and once I mark these 2 points, I can measure them using a scale. And here you go. So here you measure, it's about 8.7 centimeters. And this is also, it should be 8.7. Yep, you see that that's 8.7 centimeters. 8.7 centimeters. So if this is your object, this is where your image is. And to understand how to draw a ray diagram for, let's say, how to draw a ray diagram, let's say this is your eye, from where you're seeing. To draw the ray diagram, all you do is you extend this line from the image. So a ray must have come from the mirror like this for us to have seen this object. Now you connect from the object this ray. So as you connect this, you have that. Now if you can try to draw a normal to the mirror, and say this is our 90 degrees. This is the normal. And if you find what is the angle of incidence, and if this is your angle of incidence, this should be your angle of reflection. So let's measure them and see what are the angles made. Okay, so this angle is approximately 35 degrees. So you can see that 35 degrees. So this is 35 degrees. And you can see this angle is, let's align this. This is also 35 degrees. So you see that's about 35 degrees. So this is equal to 35 degrees. So here we prove that your angle of incident equal to angle of reflection. The second thing, we prove that your object distance is equal to image distance. And the third thing, you prove that this ray that you're getting, the ray which comes to your eyes, will always be coming from your image, or rather imaginary image or virtual image. So in reality what happens is the ray comes from the object and it reflects to your eye, and your brain projects the ray back to form an image. So I hope you enjoy this video. See you in the next one.